Okay.
So regression analysis basically looks at the relationship that two or more variables show. Um, and so we're going to look at multiple regression and see how this model is able to deduce significance. So we're told that a local gene producer engaged an economist U who estimated the demand for alcoholic beverages in Lusaka and Copperbelt towns. And based on the drink's apparent success, the company is considering a nationwide launch. The company intends to use the estimation to guide in setting prices and forecasting demand. So the data is showing 48 observations, okay, and the number of drinks purchased per week. So computers average price, income, and population. So I want to see how significant each of these figures are in explaining the variables. So we have the constant here, we have the on price, we have computers price, we have the income, we have the population. So to determine how significant each of these are, we'll divide the coefficient divided by the what? The standard error. If the answer we're going to get is more than 2, then we know that they are significant. So we're going to divide each of these values here, starting with the on price, okay? Regardless of the sign. If it's more than 2, it will be what? Statistically significant. So let's start dividing. So here, we'll start with the on price. So what we are doing basically is to calculate our T at 5%. So the coefficient over the standard error. So for the on price, negative 3,500 over 700, we're getting 5 point something. So that is more than 2. So it is what? Statistically significant at 5%. If we go to competitor's price, 4,200 over 851, it's more than 2, significant. 777 over 66 is 11 point, so it's also significant. 0.4 over 0.3, this is 1.29. This one is less than what? 2. So this one is not statistically significant. Is that true? Is that okay? Are we together so far? Okay, are we together so far?
Okay, I think I lost connectivity for a while. So we're just finding the we were still dividing. I don't know whether we proceeded from there. Yeah, a
Yeah,
bit fast
I
though.
haven't
So
I haven't proceeded. I'm just saying to find which of these
okay,
figures are significant. We're just dividing this divided by that, this divided by that. Okay?
okay,
Yeah.
okay,
Is that clear?
okay. Yeah, yeah. We can proceed. Just
Okay.
try and divide that as well.
So we now go to the second
So
part.
when dividing, like the coefficient should have this negative sign. It should
No, whether
still
it's
be indicated
negative
as
or
a
not,
negative.
the constant
We
is always
just keep it
negative.
as is.
Whether it's negative, yeah, just treat it as it is. But as long as it's more than 2.
Okay,
All right.
okay,
And the second
okay.
part will be to now explain the variation. So initially, previous class, I was trying to explain what all these variables mean. Okay? What a constant is. Okay, it would be important that you also understand the significance of each of these ones here. All right. So um, we now want to look at to what extent one variable affects the other variable. So now, in terms of understanding what each of those ones mean, I would want you to first understand also um, the constant helps us understand the y-intercept. Okay, so for instance, if you're coming up with a regression equation, which is given by the following: y is equal to 10 minus 2x. So this one is a regression equation. It simply means that the constant here is where it's cutting the y-axis. This is our 10, and our gradient is our negative 2. So this one is showing there's a negative relationship. So now if you have many more multiple gradients, for instance, you can have your constant as 10. Our x1, the gradient maybe is -2. Our x2, maybe the gradient is +5. And our r squared, maybe it is 0.93. So how do we come up with that regression equation? We simply say y is equal to what? The constant, which is 10 minus 2x1, because that's a variable for x1, it can be price, plus 5x2, that is another variable that we have. So this is how we come up with regression equations using the table. Then our r squared here, it means that this x variable, which is the independent variable, it affects the dependent variable by 93%. So it measures the extent to which this is affected.
Okay. I'm following. Mhm. Mhm. Mm. Maybe I need to cast off again.
Are you understanding altogether?
Yes, the network is really problematic. Okay, so I was with you up until um we were trying to where the independent variable, I think that's where it ended. R
So
squared is equal to
r squared, if you given
0.93.
r squared
Mm-hmm.
0.93, it means that what?
Mm-hmm.
Um, 93% of that variation affects that. 93% of this equation is significant to affect what? The regression. Okay? That's what it
Okay.
means. So I want us to
Okay.
apply this now here. So um, we've understood this first part that we did to look at the significance of these variables. Now
Mm-hmm.
we want to now calculate the r squared. So here our r squared is 0.93. 0.93. So this 0.93, when you go to the table, where is 0.93 coming from? When you go to the original table here, it's asking you how much of the total variation in cells does the regression model explain? So you could go down there, you've seen this 0.93. Okay?
Yes.
So that's 0.93 explaining that the 93% of the variation affects the entire model. That's what it
Mm-hmm.
means. So this is how
Okay.
much of the total variation does the regression model explain? So 93%.
Okay. How
Then,
much of the total vessel? So we just pick the 93.
yes, just multiply by 193. Is that clear?
Mm-hmm. Hello? Price, let's see if I can the main price. It's not too-
So are you understanding? Is that clear?
Yes, I'm understanding.
Okay,
Yes,
so
I'm
now
understanding.
we want to go to elasticity, price elasticity of demand. So price elasticity of demand, we calculate it by the coefficient of price elasticity of demand, the coefficient times the actual price over the quantity. So what is the
Okay.
coefficient of what? Um, what is the coefficient for price elasticity? We have it is what? On price, what is the coefficient? Negative 3,590.
3,590.
Okay? All together.
Yes, we are.
Negative 3,500 and what? And 90.
90. Mm.
So Um,
0.6
so that's what we'll put where? That's what we'll put here
and 6.
on the coefficient. Let's put there, try to calculate. Then the price is what?
The price is
We've been given 7.5 and the quantity is 20,000. Calculate the elasticity.
mm, okay. So, like you said, I should not mind
If
the
it,
negative
elasticity of demand is always negative. So
of
uh, for elasticity, it's negative.
1.3.
So there are only 3 points that you need to take note of. So we have 0,
Mm,
-1, -2, and upwards. So if
mm,
your answer is between 0 and -1, we will say it is inelastic. If it's exactly 1, it is
mm,
unit elastic. If it's more than 1, it
mm,
is what? Elastic.
it's
It's more than 1.
elastic. Mm,
So we want to calculate and comment whether it is elastic, inelastic, or unit elastic. So in this case, so our constant there is what? Negative 3,009, and then the price is 7.5, and the quantity is 20,000.
3,006.
What are you getting?
Mm. I got 1.346. Not sure if it's correct.
Okay. Yes, 1.346 or 1.35. So it means demand is what?
Mm,
Elastic. So
it's
we get the
elastic.
coefficient times the price over quantity. So the coefficient was negative 3,000, the price 7.5, and quantity 20,000. So
Mm,
this is that. Are we together?
mm,
Then we go to the overall significance of this. So we're asking, is the overall, so this was about 5 marks. Is the overall regression statistically significant at 1%? So we use the what? The p-value. So if the p-value
mm.
here, what is the p-value? 0.04, this is 4%.
Yes, yes, yes.
So the p-value must be smaller than the statistical significance. If it's more than that, it's not significant. So this is
Okay, let me
4%.
just write that down. Let
So
me write it down.
p-value,
You are recording this?
yes,
I'm seeing you're recording it.
yes,
Are
I'll
you
send you
able
the
to share it with
recording.
me?
I'll share the recording.
Okay, okay. I
So
think
the
that one will
p-value
help me even
must be
better.
what? Less than the significance level.
The
Okay?
significance.
So
Mm,
our significance level is what? 1%.
mm,
But here, what is our p-value? It is 4%. It is more. So here, it
mm.
is not significant. It shouldn't be the case, so it's not significant. So this one is greater, so it's not a good thing. But if our significance level is 5% here, we'll say yes, it's significant because the p-value is less than. So ideally, our p-value must be less than the significance value. So here, we're going to say the overall
Mm,
regression is not statistically significant. Why? Because the p-value is less than what? A significant level. So here,
okay,
we say at f of 4.56, our p-value of 0.04 is not significant at 0.01. Why? Because it is more than that. But if it was 5%, it would say it would be significant. All right, we're
okay.
together.
Mm. Yeah, we are.
Okay. And finally, the question is now asking us to explain what? How appropriate is this equation in terms of economic criteria? So you now need to, that one is carrying 5 marks. So for income, we need to look at the sign. If it's a positive, it is a normal good. If it's a negative, it's an inferior good. So here we can say that income, we're dealing with a normal good. All right.
Mm,
Then we go
mm,
to a competitor's price here. If it's a negative, the competitor is dealing with a substitute good. Okay. If it's a negative, it's a
mm, mm.
complementary good. So here we have a positive. So we can say, um, um,
The complementary
it's a positive, it's a substitute.
to substitute. Okay.
Mhm. Then already here, we divided this in there. We got something that was less than 2. It's not, so population is not a factor in forecasting the demand for the drinks. So that is the significance of that. So here what it means is that,
Mm,
number one, on price has a negative inverse relationship. The negative sign just shows that the higher the price, the lower the quantity demanded. Then competitors'
mhm,
price here, we are able to tell that it is elastic, so that consumers are able to switch as the prices go up. Then income, as a
Mm,
positive. So it means that this is a normal good. The income will rise with the price. Then population is
mm,
insignificant. It doesn't add value to the model. Are we together?
mm. Yes. So when answering, all these things must be outlined.
Mm. Yes, yes.
Okay.
Must be outlined. This is about 5 marks or 10 marks.
Okay.
Mm.
Oh, okay. So this is what's most important, because if it takes 10 marks, it's like the half of the question.
Yes, yes, yes. It's like half of the question.
Mm, mm,
All right.
okay. Okay. I think it just needs a bit more practice. Since we're writing next week, Monday,
Next week,
I
Monday. All
can
right.
get some people to, yeah,
All
to
right.
join, because most people are just really, this is basically one of the topics that I think just by the term regression, you're even scared. You're even choosing already what you're going to write in the exam,
Yeah, in the actual
and you
sense.
exclude it, but it's there. Like it's most of the questions that
Mm.
our lecture is, the questions that it gives yearly, you find there's regression. Every question paper actually. So I don't know where you got this question from.
Yeah, I got it in the past papers. I sent the past papers to you. So there are several
For
regression
for
questions.
which
Let me check
for
it out.
which for which school?
Mulungushi.